My dear students, welcome back once again on my platform. My name is Lamiya Naseem, and in today's session, we are going to derive one expression named Mayer's formula. What is the name of this expression? Cp minus Cv is equal to R, Mayer's formula or Mayer's equation. My dear, it is basically a part of 11th class physics. You have one chapter na thermodynamics. So in which you will get this topic, which I am going to discuss separately. Okay. Or if you have some another topic related to the physics, related to the mathematics, please share with me in a comment section so that I can create that video also. So without any delay, let's start the session. So the very first thing we have to prove Cp minus Cv is equal to R. How we are getting this expression? Okay. So what I am going to do, I am going to consider one constant volume process. Okay. So this is my container. All the boundaries of the container is fixed. Where we are getting boundaries, ma'am? Try to understand. This is one boundary. Okay. This is one boundary. Then you will get another boundary at the bottom because this is a cylindrical container. And obviously the surface of the cylinder. And no boundary is movable. All the boundaries are fixed. What boundaries are doing? Boundary separating the system from the surrounding. Okay, boundary separating the system from the surrounding. Now what I am going to do, I am going to consider some molecules. Okay, suppose that total 1 mole of gas molecules are considered, only 1 mole of gas are I considered. And what I am going to do, I am going to provide some amount of heat into the system. So let us consider del Q amount of heat we are providing into the system. Okay, as I already told you, all the boundaries of the system is fixed, so no doubt you will not get any work transfer. Okay, if boundaries are not moving now, so you will not get any work transfer. Or always remember, if you want a work from a system, minimum one boundary should be movable. Okay, and everyone aware about the first law of thermodynamics. What is first law of thermodynamics? Let's talk about first law of thermodynamics. Okay, so the formula of first law of thermodynamics is del Q is equal to the du plus del W. Okay, as this is the closed system. Okay, as this is the closed system, what is the formula of del Q? Now you will say, ma'am, it's a constant volume process. The formula of del Q will be equal to the mcv delta T, change in temperature. Okay, so what I am considering, let us consider this container initial temperature is Ti, and when you add the heat into the system, no doubt temperature will change, temperature will increase. So let us consider final temperature is Tf, and when you consider the change in the temperature now, so what you will get? T final minus T initial. Okay, when you consider the change in the temperature, what you will get? T final minus T initial, that we are putting here. Okay, now let's talk about the work transfer. What is work transfer formula for a closed system? That is your PdV. As we already know, it's a constant volume process. Volume is not changing, so change in volume will be equal to the 0. If change in volume will be equal to the 0, so what is the work transfer? Will be equal to the 0. Very easy. Now in first law of thermodynamics, try to put all these conditions. Okay, so in place of del Q, I am going to put mcv dt is equal to the du, and in place of del W I will put 0. So from this expression, now you can, my dear, understand. Okay, now you can easily understand your du value will be equal to the mcv dt. This is my first expression. Now why internal energy is changing? My dear, always remember, internal energy is a function of temperature. Okay, internal energy is a function of temperature. If temperature will change, definitely internal energy will change. Okay, and internal energy never depend upon the type of process. Okay, because internal energy is a state function. Always remember, internal energy is a state function, or we can say that internal energy is a point function. Okay, it is not depending on the type of process. Okay, it is depending on the only on the end points, only on the state of the system. Okay, but if we are talking about the heat transfer, if we are talking about the work transfer, these two are path function. Okay, heat transfer and work transfer is a path function. That's why if you will change the process, all these values will change. If you change the process, all these value will change. Okay, so what we are going to do, we are going to consider one more process. Let us consider we are dealing with the constant pressure process. Okay, so initially we have this container, and fluid is somewhere here. Now what you are doing, you are adding heat, q input, you are adding heat into the system. When you add the heat into the system, what will happen, the piston will move in the upward direction like this, and you will get some amount of change in volume, so no doubt, if we will do the calculation for this case now, for this process, definitely you will get some amount of work transfer, because one boundary is moving, your piston is moving in the upward direction. Okay, so again try to apply the first law of thermodynamics. Whatever I am sharing small statement now, please try to write down on the notebook, because all these statements are very important. Okay, now try to understand what is first law of thermodynamics. Del q is equal to the du plus del w. Now for a constant pressure process, what is the value of heat transfer? No doubt cp mcp. Okay, what is the value of heat transfer? mcp dt. What is the value of work transfer? Work transfer value you will get, because you are getting change in volume na. Here pressure is constant. If pressure is constant, then no doubt change in pressure will be equal to the zero, but volume is not constant, volume is variable. Okay, so you are, if you will put all these value in first law of thermodynamics now, you will get one more expression. What is that expression? mcp dt is equal to the du plus pdv. Okay, now my dear, try to understand, this is my second important expression. You already find the value of net internal energy change. Ma'am, how is it possible we are going to use this du in this particular expression? My dear, we can use, do you know why? I already told you internal energy is not depending on the process, it is just depending on the end point. If we are considering constant pressure process and constant volume process between two same state na, then after we will be able to use this expression. What I am saying to you, try to understand. If you are considering like this is your pressure, this is your volume. Okay, you are creating a constant pressure process, you are creating a constant pressure process, you are creating a constant volume process like this. Okay, so process is different, no doubt, but the change in temperature which you are considering, that we are considering same. Okay, as internal energy is a function of temperature only, it is not depending on the process, then no doubt here we can use the data of equation number 1. Okay, equation number 1. So put it here, mcp dt is equal to the, okay, what is the value of du? The value of du is mcv dt plus p dv. Now what I am going to do, I am going to shift this mcv dt towards right, left hand side basically. So when you shift it towards left hand side, my dear, what you will get? What you will get? Just give me a second, let me add one more page basically. You will get mcp dt minus mcv dt is equal to the pdv. This is my first, basically this is my third equation. Now for ideal gas equation, for ideal gas ideal gas equation, you know one expression, pv is equal to the mrt. Okay, now differentiate it. We already know the process of differentiation. If we are considering pressure is changing, volume is changing, temperature is changing, so here you are getting two functions na in multiplication. So what is the process to differentiate two function? Okay, process to differentiate two function u and v with respect to x, d by dx u into v. Okay, so what is the formula? First function as it is, differentiation of the second function, plus second function as it is, differentiation of the first function. The same concept you have to apply here. P as it is, differentiation of v is dv, v as it is, differentiation of p is dp. Mass and gas constant is already constant. Okay, mass and gas constant, these two terms are constant, so you just need to differentiate t, so you will get dt. Okay, so if you are considering this condition for a constant pressure process, so your change in pressure will be equal to the 0, so this term will be equal to the 0. If this term is equal to the 0, then my dear, what you will get? In place of pdv you can put mr dt. Okay, now in equation number 3 put this value, you will get mcp dt minus mcv dt is equal to the mr dt. Okay, now try to understand. You are observing some common terms जैसे कि mass you can cancel it out, delta t you can cancel it out. Okay, so when you consider mass as a common term, when you consider delta t as a common term, so what you will get at final condition? You will get cp is minus cv and you will get only r. And I think this is the Mayer's equation. Okay, this is the Mayer's equation and this is the proved. Okay, this is the final expression, basically proof of Mayer expression. Okay, this is our final answer. So hope so you get proper idea what we did. Try to summarize it with me. Okay, first we considered constant volume process. We created one expression with the help of first law of thermodynamics, and obviously internal energy is a function of temperature. We created one expression irrespective of the process. Okay, now we considered constant pressure process and then we applied first law of thermodynamics again. We created one more expression, equation number 2, and in place of du we put our equation number 1 value. Okay, so we got like this expression. Now for ideal gas you can take pv is equal to the mrt, then you can differentiate it, and once you put all these value then you will get cp minus cv is equal to the r. Okay, so hope so you get proper idea of the derivation. If you like the video, please like the video, subscribe the channel and share with your friends also, because as you know this is my new channel, so I need your support. Thanks a lot. Goodbye, take care.